Oh, whatever. Testing. Whatever. Hey, got it's it got garbage audio, but whatever. Garbage audio as usual. But let's just get this.
Hi everyone, in this episode we're going to continue our look at the transform component, looking at the differences between global, object, and local space, as well as how to parent, rotate, and scale objects from script. So I have the simple scene set up with a sphere and a cube object, and I'm just going to go up to the top here and make sure that I'm in global space mode, as this is what I want to talk about first. So as you know, our 3D space is defined by three
Okay,
axes, the
sure.
forward Z axis, the vertical Y axis,
I already forgot where that was. I already forgot. Great. It's like, somewhere, it's here. It's right here. Oh.
and the horizontal x-axis. Global space refers to the fact that the directions of these axes are constant throughout our world. I could rotate an object to face a different direction, but the global directions of course still remain the same. Let's now change to object space. The label here says local, but you'll see a little later on why I prefer to call it object space instead. So in object space, all directions are considered from the point of view of the object. So having rotated the cube, forward is now in this direction, and the x-axis is in this direction.
Okay.
Let's have a little discussion about parenting. So I'll reset this cube object so that it's back to 0, 0, 0 in the world. And notice that the sphere object is positioned at 2, 0, 0. If I now grab the sphere object in the hierarchy and drop it onto the cube object, I've successfully parented it to the cube. So we say that the
Yep.
sphere is a child of the cube, and conversely, of course, the cube is the parent of the sphere. All that this means is that the position, rotation, and scale of the sphere are now all relative to that of its parent. So in the inspector, the values we see for position, rotation, and scale are all relative to the parent, and we call them local values. This is why if I were to move the parent, say, 2 units to the left, the position of the sphere in the inspector still reads 2, 0, 0, as it is indeed still 2 units away from the parent on the x-axis. The sphere's position relative to the world, that is to say its global position, is of course at this point 0, 0, 0, as we can see if I quickly unparent the sphere from the cube. I'll reparent the sphere, and let's look at what happens if I now rotate the parent. So of course the sphere rotates along with it. Looking at the values in the inspector once more, we can see that the local values remain unchanged, as despite the rotation, it remains 2 units on the local x-axis away from its parent. Alright, now let's say that I rotate the sphere a little bit, so it's no longer facing the same direction as its parent. Here's a quick test. If I were to manually increase the sphere's Z position in the inspector over here, what direction will the sphere move in? Forwards globally, forwards relative to its parent, or forwards relative to itself?
Um, Relative to itself.
The correct answer is forwards relative to its parent. So this is the
Oh,
distinction
what
between object
the
space and local space, which I alluded to earlier.
Okay, never
Local
mind.
space is relative to the parent, while object... So this is its parent, or forwards relative to itself. The correct answer is forwards relative to its parent. So this is the distinction between object space and local space, which I alluded to earlier. Local space is relative to the parent, while object space is relative to the object itself. Right, so I've reset
Okay,
the scene
sure.
back to how it was at the start, and let's experiment with some of these things now through script. So I'll just right-click, create a new C# script, and maybe call it something like cube script. And I'm just going to attach that to my cube object, and then we can open it up. So let's say that we want to parent the sphere object to the cube object. the first thing that we'll need is a reference to the sphere's transform. So the easiest way to get this
Okay.
would object to the cube object, and then we can open it up. So let's say that we want to parent the sphere object to the cube object. The first thing, and then we can open it up.
Let's say that we want to parent it. Okay. Um, sure. Why not? And what he does is he just does it immediately. He just puts it right on the cube immediately. And actually, yeah, I want to move that there. Okay, actually this is not the cube I want. Yeah, okay, that's good. Now I'm gonna make a new cube. Actually, I'm just gonna duplicate this one. And then I'm gonna move that. Cool. And now we do this. Oh, we do public game object child, I guess. Is that correct?
So let's say that we want to parent the sphere object to the cube object. The first thing that we'll need is a reference to the sphere's transform. So the easiest way to get this would be to just make a public transform variable up here. We can call this sphere transform.
Okay.
And then if we save that, because it's a public variable, it will show up in the inspector here, and we can just drag the sphere into that slot. And then
Ah. And I have to do this actually.
Then in the start method, we just want to set the sphere transform's parent, so we can write sphere transform dot parent, and we want to set this equal to the transform of the cube. So since the cube script is attached to the cube, we can simply write is equal to transform. So if we save that and go into Unity, attached to the cube, we can simply write is equal to
Yeah, I guess I'll just do this. And then start. Am I doing this correctly? Is my nose bleeding? Oh, cool. It is. Hold up. Okay, what? Why is this asking me to update? This isn't Visual Studio 2019. Okay, great. That's my name. Cool. Uh, and that's my email again. Great. Okay, can't you just do this? Like, can't you just do this? I'm like kind of confused.
To transform. So if we save that and go into Unity, you can see that in the hierarchy, the sphere is not parented to the cube, but as soon as we press play, it'll be parented through our script. We haven't yet.
Oh. Okay. Okay, I don't want that. Ah, sure. I don't know what this is telling me. Oh, cool. Yeah, never mind then. I thought I already downloaded that. I guess it only works with 2019. Unity only works with Visual Studio 2019. Great. Never. Okay. I like Okay. Nice.
Looked at how to rotate objects with our code, so let's have a look at that. In the update method, if we just write transform.rotation, you can see that rotation is stored as a quaternion value. Quaternions are a little bit tricky, and we'll definitely discuss them later on in the series, but Unity does provide a much more intuitive way of working with rotations, with the Euler angles variable, which you can see is just stored in our familiar vector3 format. So if we wanted to increase the Euler angles over time, we could just say transform.eulerangles plus equals, and we could create a new vector3. So we want to rotate it on the y-axis, so we just say 0 for the x, and then for y we could say maybe give it a speed of 180 degrees per second, so we'll need to multiply that by time dot delta time, and then just 0 for the z-axis. Let's save that and give it a try. So if we press play now, the cube is rotating around, and of course since the sphere is parented to it, that is rotating, and then just 0 for the z-axis.
Huh. Sure. We just think here. This makes it apparent. Okay. Sure. Transform the Euler angles. Okay. Sure. So X, Y, Z? So Y, where's Y? Y should be vertical. What? Oh, okay. So it rotates it in. Like, whichever direction it's pointing, it rotates it around that. Got it. Around the axis. It rotates it around the axis, not like towards the axis, I guess. Alright, sure.
Let's save that.
So, sure. Easy enough, I guess. I'm a little bit confused about this part, but I guess it doesn't really matter right now. Okay, I'm sorry, there's a fly in my room. Okay, cool. So, 180 degrees. So this is per second. Okay, that is per second. Haha, haha. Okay. That's not what I wanted to do. Ha ha ha. Okay, can I? Ha 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 ha. Okay, whatever. But sure. That's easy enough, I guess.
And give it a try. So if we press play now, the cube is rotating around, and of course, since the sphere is parented to it, that is rotating around with it as well. I think it's definitely worth mentioning that an alternative way of writing this would be to just say new vector 3, 0, 1, 0, and then to multiply that by the speed. So what you'll often see people do is, instead of writing it out like this, they'll use the shorthand vector 3 dot up, which, as you can see from the summary here, is just another way of writing 0, 1, 0. And this shorthand does exist for all other directions, for example, forward or left, and so on. But let's just leave that at up. And if we go back into...
Okay, that's easier. That's easier, actually. That's actually easier. I'll just like comment this out. And then comment this out. Because I'm just gonna do this here. Then copy this. Please, can I please? Gonna have to get used to pressing that. The 8 key. And times this. And that's so much easier. Okay, I did something wrong.
Unity now, left, and so on. But let's just leave that at up.
Did I mess something up? Cannot be used in object creation.
For example, you can see from the... What you'll often see people do is, instead of writing it out like this, they'll use the shorthand vector 3 dot up, which... So what you'll...
Got it. Okay. Okay. Fair. Fair.
Often see people do
That's so
is,
much easier,
instead of writing it out
yeah.
like this, they'll use the shorthand vector 3 dot up, which, as you can see from the summary here, is just another way of writing 0, 1, 0. And this shorthand does exist for all other directions, for example, forward or left, and so on. But let's just leave that at up. And if we go back into Unity now and just press play, you can see that it's still got the same result.
Forward, left, right. Oh, got it. Up, down, forward, back, left, right. Okay.
But let's now
Fair.
grab the cube and just rotate it a little bit. And if we press play now, we can see that it's rotating around its global y-axis. In other words, this would be rotating around its local y-axis, and it's instead rotating like this. So let's see how we could change that. So in MonoDevelop, we can use the proper rotate method. So you can see this takes in Euler angles, so we can just pass in what we had before, vector 3 dot up, multiplied by time.delta time, multiplied by 180. And now, by default, the rotate method works in object space. So if we press...
Okay. Sure. Okay, sure.
play, we'll see automatically this is now rotating around its local y-axis. If we want to specify that it should work in global space, then we can just add a comma, and we can add this extra space parameter, space dot, and we can choose between self, which is object space, and world, which is obviously global space. So if we change that to world and save, and press play, we can see that we'll have the behavior that we had earlier. Now, last episode we looked at the translate method, and...
Okay. Yeah, I'll just do this. Fine. Fine. Okay, never mind. I'll just do it without a comment first. That is not even close to what I meant to do. Do I have to do new vector 3? No. Because it's already vector dot up. And just do this. And also... what else did he say? Oh, yeah. Okay, cool. I mean, at some point, I'm just like not even gonna need
And
this.
that method works similarly to the rotate method. So if we say transform.translate, and say we just want to rotate vector3.forwards, multiplied by time.delta time, and multiplied by some fixed speed, say maybe 7. By default, this will also be translating in object space. So we can see that if we press play, as this is rotating around, it will move forwards in the direction of the rotation. If I change the visualization over here to
What?
object space, we can see a little bit better what's happening. It's just following its own forward axis around and around. If, of course, we change this in the same way, it's just following its own way. By
That
default,
didn't
this will
do
also
anything.
be translating in, and say it works similarly to the rotate method. So if we say transform.translate, and say we just want to rotate vector3.forwards, multiplied by time.delta time, and
Wait a second. Oh. Okay. I'm a little confused. Wait.
multiplied by some fixed speed, say maybe 7. By default, this will also be
So, that's local, but...
translating in object space. So we can see that if we press
By
play, as this is
default,
rotating around, it will move forwards in the direction of the rotation. If I change the visualization over here to object space, you can see a little bit better what's happening. It's just following its own forward axis around and around.
Huh, that's so weird. Wait, so what is the other script that I wrote? Like this, what is this? I don't even need to open it. I don't know why I'm doing that. Huh. Because, is it because it's forward? No, oh, this is transform dot translate? Wait.
To forwards in object space. So we can see that by default, this
I'm a little confused. Huh. Vector 3 input. Okay, input dot get axis raw. What does that do again? returns the value of the virtual axis identified by axis name. Okay, so this isn't local. Wait.
This will also be translate and say we just want to rotate vector3.forwards, multiplied by time.delta time, and multiplied by some fixed speed, say maybe 7. By default, this will also be translating in object space, so we can see that if we press play, as this is rotating around, it will move forwards in the direction of the rotation. If I change the visualization over here to
I guess
object
so. Forward, back, up, down, left, right is always local. All right, got it.
space, you can see a little bit better what's happening. It's just following its own forward axis around and around. If, of course, we change this in the same way as the rotate method to be space.world, we'll see that it now operates, of course, in global space and just heads off along the global z-axis.
Okay.
All right, let's perhaps try setting the scale of our sphere object from the script. So maybe in the start method, we can say sphere transform dot local scale is equal to, and we can set this equal to a new vector 3, say 2 by 2 by 2. And the sort of alternative shorthand, once again, for writing that would be vector 3 dot 1 multiplied by 2. So if we just try that out, when we press play, the sphere should increase in size, as it did. Finally, just to experiment with setting the position.
Sphere transform dot local scale. Local scale, what is that? Local scale. I just do this. No, I have to do it on a pre-existing object. What? I didn't. Did I oh, I guess I did. Okay. Local scale. Huh. Because this is, it's just referencing, it's just basically a convoluted way of saying change the scale of the object that this object is attached to, or the object that's attached to this object. Huh. Okay, hold up. If I do this, what happens? What happens if I do that? No, it doesn't, because it's only the transform. It's only the transform. It's not actually the object, but then how does this like make the object bind to the parent? That's my real question. Like, what the fudge? Huh. So, I mean, it only binds if it's like with something? If it's with like an expression, I guess. Like, what is this called? An expression? I guess that's all I can think of right now. Child transform dot parent equals transform. Wait, I could do this like a different way, right? If I did public game object child, and then I did transform dot child or child dot transform. Let's see, game object dot transform. Is that right? That would be less confusing, correct? Can I print this? Or is that not gonna work? Transform does not contain a definition for print. What? Oh. Yep. So if I do this, I'm guessing that's not gonna work because it's not a string, maybe? Unless it's gonna switch it automatically. Oh! It didn't do it. It didn't print the transform, but whatever. Alright. If I just do this, what happens? Okay, it just prints parent cube. Wow. So it's like effectively the same thing, I'm assuming. Except this only changes the position, the rotation, and the scale. I guess? And I guess this kind of has to occur. Like I have to type this in order to bind them, to bind it. Yeah,
versus the
I
local
guess that's
position.
fine.
Let's say that if
Sure.
the player presses the space key, so we can say if input.getKeyDown, keycode.space. Let's first say sphere transform.position, so in other words, the global position is equal to vector 3.0. So in this case, if we play,
Whoa, 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 bro, what?
the global position is equal to vector 3.0.
Okay, then it's just going to set it to 0, 0,
So in this case, if we play and press spacebar, you can see the sphere will keep getting reset to global 0, 0, 0. And if, on the other hand, we change this to local position, you can probably figure out what would happen. When we press spacebar, it will just snap to the position of its parent since of course a local position of 0 indicates a 0 offset from the parent. Alright, that is everything for this episode. Thank you very much to the 0 global 0 and press spacebar. You can see the sphere will keep getting. If on the other hand we change this to a local position, you can probably and you can see equal to vector 3.0, reset to, in this case, local position. You can probably figure out what would happen. When you press spacebar, it will just snap to the position of its parent, since of course a local position of 0 indicates a 0 offset from the parent. Alright, that is everything for this episode.
Okay.
Reset, change this to local position of the parent.
Yeah, that's fine.
Introducing some cutting-edge technology that...
Okay. I don't care. Thanks. Thanks, I don't care. Let me just like do some stuff on my own, honestly. So I'm gonna do okay, let's do transform dot position. Okay, actually just kidding, transform dot translate. And this only takes a vector 3. Alright, sure. So vector 3 dot up. Times I guess time dot delta time. So that's going to make it move up, and then let's do the transform dot Euler's angle, I guess. And really, I could just put this in 1 here. I could just put this as new vector 3. And let's see, I want it to rotate horizontally, so sure, let's do 1, 1, 1, 0 times 1, sure, but I guess this is only if I want it to be the same speed. And let's see what happens then. What I'm expecting is so I'm expecting it to rotate this way, like this way. Like, okay, I guess I can just do this, rotate this way. And also rotate this way. So what is that going to look like? It's going to go like . I mean, it might go this way, actually. It might go that way. Let's see, what is... Okay, no. It is gonna go the other way. So, we just like do the vector in my head here. So it's gonna go like this, like around that axis. Okay, let's see if it actually does. Really? Is this not working? Why is this not working? Let me just see if this by itself is working. Yeah. Okay, so it is. That's working. Now let's see if this is working. Okay, it's still only doing the vertical one. Is this like not possible? Or am I just like messing something up? I'm like kind of confused. Okay, that's working. And if I do this, if I do this plus equals vector 3 dot, I don't know, left, left, sure, times this. See what happens. Should we be rotating this way? Okay. Uh, that's my problem. I don't know why this isn't, I don't know why there's an error here. Oh, that's why. No. Oh goodness me, why is there so much stuff to keep track of? 0, 1, 0. I mean, am I like
Hi
not
everyone, in this episode
doing this correctly?
we'll get key down.
Oh. Meet Jessica Moore. Jessica was born to care.
Oh my gosh, bro, I don't care.
Hi everyone.
I don't care. No. But now there has to be a parentheses somewhere else. And where?
Hi everyone, in this episode, if on the other hand we
What the fudge? I can seriously only do this. So this has to be a rotate. Sure. Okay. And it's like the same thing. Okay. There you go. And that should work now. There you go. Yep, that's about what I expected. Cool. I'll save that. That's
change this to local.
that's good. Stupid ads.
At rigid bodies. So rigid bodies are
Okay, so I like already know how to do this, kind of. So I might just like skip this one.
Hi everyone, in this episode we're going to be looking at rigid bodies. So rigid bodies are objects that are controlled by the physics engine, meaning that we can apply forces to them and they'll react accordingly, colliding with other objects in the scene. If we want to move an object but don't care about collision,
Okay, so this is just collision detection. No, but I'm assuming he's gonna
we can just
also introduce me to, I forgot. It's like something to do with physics, like the push, like you
move it with
push
transform to
instead
translate
of
inside of the update
translate.
method, as we've been doing. If we want to move an object but don't care about collisions, we can just move it with transform to translate inside of the update method, as we've been doing up until now. As you know, the update method gets called just before the scene is drawn to the screen. So the first update occurs at time 0, and then perhaps 15 milliseconds later the update method is called once again. It moves the object to its new position, and the next frame is drawn. Now imagine for whatever reason that the frame rate drops, and the next frame is drawn 65 milliseconds later. The object obviously needs to move a lot further between frames 2 and 3 than between frames 1 and 2, since more time has passed. As we've talked about before, this is why we always multiply our object's velocity by delta time, the time between frames. Now there's another update method called fixed update, which we almost always use when we're working with rigid bodies. Unlike update, fixed update doesn't care when the scene is drawn, instead it's called at a fixed interval, the default being every 20 milliseconds. So we'd have our first fixed update call at time 0, then 20 milliseconds later it would be called again. Note that the object's new position will not have been drawn onto the screen yet, because fixed update was called after the last frame was drawn. So fixed update continues to be called every 20 milliseconds, and the object's position is updated inside of the physics engine. Finally, at the 80 millisecond mark, the object's position is drawn onto the screen. Now, all of these extra fixed update calls might seem like a waste of processing power, since the player obviously only sees the result when the frame is actually drawn. However, when dealing with physics, these extra calculations are necessary. If there's a wall we want to collide with, for example, but the frame rate drops, we still need to calculate all the in-between steps so that the object doesn't simply pass right through it. If the object is moving very fast, of course, it's still possible that it won't collide with the wall even in fixed update. To rectify this, we could simply increase the rate at which fixed update is called, making it, say, every 5 milliseconds instead of every 20. Obviously, this would come with a huge cost in processing power, though, so in later episodes we'll discuss techniques for dealing with very fast-moving objects such as bullets, but for the vast majority of cases, our fixed update every 20 milliseconds will handle collisions just fine. Let's have a look at how we do all of this stuff inside Unity. So to start with, I'd like to create a player object that I can move around the scene and just have collide with obstacles. So let's create a cube object, and I'll just rename this to player. And then if we go onto the component of Unity. So to start with, I'd like to create a player object that I can move around the scene and just have collide with obstacles. So let's create a cube object, and I'll just rename this to player.
Sure. Let me just duplicate this. I mean, I'm just too lazy to apply the color again and everything. So I'm just gonna do that.
And then if we go onto the component menu, we can go physics and add a rigid body component so that the object is now physics enabled.
Yep. Forgot about that.
You can see if we press play, the object will fall down because gravity is being applied. So let's create a plane object to act as a sort of floor.
Yeah. What
and we can just move
in the world?
So let's create a plane object
What did he
to
just
act as
do?
a sort of floor. And we can just move the
Oh.
player.
He has like a different like view. I'm so confused. What does that do, bro? Okay. Audio on or off, 2D draw mode. Oh, he has shaded wireframe. That's why.
Here above that.
Okay.
And let's maybe just scale this out to 10 by 10. So if we press play now, the player will come to, maybe just scale this out to 10 by 10.
Does this already have a, oh, it does. Okay, it does already have a mesh renderer. Cool. Actually not what I meant to do. Super epic.
So if we press play now, the player will come to rest on the ground plane. Let's create a C# script called player, and I'm just going to attach that to the player object and then open it up. Alright, so to start with, we're going to want to get a reference to the attached rigid body component. So up the top here, let's create a rigid body variable. Just call this something like my rigid body.
My rigid body. Ah. Sure, player. Let's do physics player. Physics player. Okay, attach that. Open it. Sure. Rigid body. Player rigid. Oh. What? Sure. Got it, and then we. Okay.
And then we can set that inside of the start method by saying my rigid body is equal to, and then we'll make use of the getComponent method. Now the getComponent method is what is known as a generic method, and I'll talk more about these in a later video, but the syntax differs slightly from calling a regular method. We start off with a pair of angle brackets, and then as per usual, we end off with a pair of parentheses and a semicolon.
Not the angled brackets.
So inside of the angle brackets, we need to specify a type, and in this case, we're trying to get a component of type rigid body, so we simply write rigid body between the angle brackets. So now we'll be moving the rigid body around in the fixed update method, but we still want to get our input inside of the update method. So let's create a vector3.
There doesn't need to be a space there.
And call this input inside of the update method. So now we'll be moving the rigid body around in the fixed update method, but we still want to get our input inside of the update method. So let's create a vector3 and call this input is equal to a new vector3. So for the x-axis, let's get input dot get output, but we still want to get between the angle brackets. So now we'll be moving the rigid body around in the fixed update method, but we still want to get our input inside of the update method.
Still want to.
So moving the rigid body around in the fixed update method, but we still want to get our input inside of the update method.
Okay, sure. Sure, I guess that's guess that makes sense. Okay, cool. Then we got. What does he do? Vector 3? Sure, vector 3. Input equals new vector 3. Get axis. Sorry, input dot get axis raw. Okay. Horizontal. Actually, you know what? I am gonna do that. Except yeah. Hold up. Input dot, you know what? I'm gonna say dot press dot key down key get key down key code dot space. Does that not work? Yeah. Bool to float. Cannot convert from bool to float. Why not? Do I seriously have to make another freaking variable for this? Okay. Space res. Okay, wait, I have to do this. Right? Yes? No? Do I have to? Yes, I do. Uh, oh, yeah. Oh. Sure. That, I don't know why I'm doing this. This is kind of convoluted. Why the fudge am I doing this? Like, I don't need to... I mean, there's probably an easier way to do this, but whatever. I don't know what I'm doing, bro. Please. Can you please? Okay. I'm absolutely tripping out. What is going on? Am I like seriously not? Okay. Am I like completely effing something up? What is going on? Why is that going all the way down there? What? What is happening, bro? Oh. Yeah. Let me just do this. Okay, that is better. That's better. That's better. Thank you. Thank you for that. That is so convoluted. There has to be an easier way to do that. Um, yes. Yes. All right. Nice. I'm thinking I should make this just a little bit smaller. No, that's not what I meant to do. Sure. Preferences? Is there a preferences? Okay. Fonts and colors. Size, let's just bump that down to like 15, I guess. Okay, that's maybe too small now. I'm probably not gonna make anything larger than this, right? Anything longer than that? Okay, maybe 20 was fine. I mean, I guess I could just like I can just do this kind of thing and it'll be more readable.
So
Oh, okay. And then yes. Yes. Cool. And then I completely forgot how to do physics
let's create a vector 3
once.
and call this input is equal to a new vector 3. So for the
I guess that's fine. Now how am I going to do this? Input dot something. I don't know. I don't remember. Never mind. Thought I heard someone. Yeah, I forgot. Whatever.
x-axis, let's get input dot get axis raw, horizontal, 0 for the y-axis, and then for the z-axis, input dot get axis raw, vertical. All right, and then we can create a vector 3 direction will be equal to input dot normalized, and then we can figure out our velocity from that. It will be the direction multiplied by some speed value. So let's create a speed variable up at the top here. Maybe make that public so we can edit it in the inspector. Public float speed, I'll set it equal to 6. So now we can say vector 3 velocity is equal to direction multiplied by speed. All right, let's go ahead and create our fixed update method. So just like update, fixed update is called automatically by monobehavior, so we don't need to worry about calling this method ourselves. So inside of here, we're going to want to be able to access the velocity variable. So instead of declaring it inside of the update method, I'm actually going to declare it up at the top here, vector 3 velocity. So now when we want to move our rigid body around, we can simply say myrigidbody.position plus equals, so we'll add to it the velocity multiplied by time dot fixed delta time, which is just the time between fixed update calls. Now, as I mentioned earlier, fixed update is called at a constant rate, so time.fixedDeltaTime won't change unless we change it ourselves, if we want more or less frequent physics updates, or if we modify the game's timescale for cool slow motion effects. It's worth mentioning that we can also just write time.deltaTime. It's smart enough to realize that it's being called from inside of the fixed update method, and it will return the correct fixed delta time value for us.
Okay. Sure.
All right, so let's save this and go into Unity. I'm quickly going to create a new cube object to... All right, so let's save.
Yeah, I forgot. I do need to do direction. Yeah, yeah, that should be fine, I guess. Yeah, yeah, that's fine, I guess. And this doesn't really, I don't really need to specify that that's private. Vector 4? No way that's actually a thing. Please don't. Oh my. Okay, I was joking. I was joking, but alright, sure. Wait a second. Oh, speed. Speed. Oops. Actually, float? Do I guess? Sure. Cool.
Save this and go into Unity. The correct fix.
I'm confused about this, actually. What? So it's moving the rigid body and not the object itself. Sure. Let's see, what did I F up? Nothing? Oh, yeah. Yeah, that's about what I expected. Huh. It's really not working. Wow. Okay, that's why. That's why it's not working. Whoopsie. Sorry. And that's good enough. And I can't move it. Oh, I don't have speed. I don't have any speed. Whoops. Um, just have to actually know where that is. Where the heck? Where is it? Public? Whoops, public. Sorry. Let's just do 20 for now. 20. Nothing is happening. Because I'm assuming he trolled the fudge out of me. Alright. He did. He 100% did troll the fudge out of
Stop
me.
the time value for us. All right, so let's save this and go into Unity. I'm quickly going to create a new cube object to act as an obstacle. We can maybe just spare a moment to create two materials just so we can see what's what. Call this the player, duplicate that, call this obstacle. Maybe make the obstacle a sort of reddish color, and the player can just be a dark gray. Just assign those quickly. And then from the top here, I'll just duplicate this obstacle a few times, and maybe just scale it out.
Whoa, is he doing that how I think he's doing that? Yes. Hey, never mind. I just... Okay. Black 1, black 2. Okay. Never mind. And I'm not actually sure. Did I... redo clear selection? Redo select black. Redo paste layer. Never mind. I think that I don't think I messed anything up
I'll
there.
rotate this one. I'll just get a very simple scene set up. And then let's enter play mode. So we can move the player about with the arrow keys. And if we walk into one of these obstacles, you can see that we don't just move right through it, thanks to the rigid body and the physics engine. We might not want this sort of rotation to happen when we're colliding with things, so what we could do is go into the rigid body here, open up the constraint settings, and just say freeze rotation on all axes. You can see now if we collide with something, we will no longer rotate. Let's say that we want to create some coins to scatter around the world that the player must go and pick up.
Okay, is this not gonna work? Like, it should work. Is it not working, please? Okay, maybe this was like a little bit too ambitious or something. Oh, no, it's literally just not working. Nice. Cool. Um,
Right through it, see what's what. Going to want to...
did I do something wrong? Okay. I like did everything. I set my speed, I did my rigid body here. I mean, like, seriously. What is going on? Let me just check something. Oh, that doesn't work. Huh. I'm so confused. Okay, never mind. Guess I'd have to make a new one. Makes sense. Alright. I mean, did I seriously, like, do something wrong? Looks pretty much the same to me. I'm so confused. What is going on? What is happening? What? I really hope this isn't like a Unity bug. Please. X, Y, Z. It says it's moving, but it's not. It's not moving. It's really not moving. Okay. Sure. No, I don't want the prefab view, please. Can I... No, this is not what I want. I mean, where did I put this? Where did I just... Oh. Okay, let me reset that. And you know what? Sure, let's just put the player. Oh, no rigid body. Whoopsie. Thank you. It's not working. Nothing is working. Nothing is working. Uh, like... Just so confused. Wait, does this need to be... What? Physics player. You know what? Let's just do like 100. And let's see what happens now. Nothing. Wow. What is happening? Actually, what is going on? And do I actually have to delete this? Well, actually, just kidding. I don't have to delete it. Please don't tell me. Okay, thank you. Yay. This is 0. Okay. Sure. Okay, what is... Seriously, what is going on? Like, yikes, man. Aw. Time to do some debugging. Okay. What? Wait. I'm actually so confused. Input.getAxis raw. Horizontal, did I spell it correctly? Yup. Okay. Uh, Alt negative A. Alt positive D. Yep, that's correct. Alt negative S. Alt positive W. It's all correct. I don't know what is going on. I'm so confused. What is happening? Okay, you know what? Let me just restart the program because this shouldn't be happening. Okay, great. Like, is my keyboard broken or something? I'm so confused. Like, what is happening? Yeah, my keyboard is working. My keyboard literally is working. And, let's see here. I need to open a script here. Ah. You know what? Never mind. Line by line. Line by line it is.
That we can also just write time dot delta time. It's smart enough to realize that it's being called from.
Okay. Public float speed. Cool. Vector 3 velocity. Rigid body. We have a rigid body here. Yup. Okay. Vector 3 input equals a new vector 3. Input dot get axis raw horizontal 0. Input dot get axis raw vertical. Like, okay. Let's just do this for now. Because if this doesn't work, then that means there's something very, very wrong. What is going on? Wait, it's literally just not registering my keys. It's not registering any of my keys. Alright, okay, I guess that's it for this stream. What the fudge is... I have no clue what's going on. Okay. You know what? This is what I'm gonna do. I'm gonna make a script here. Debug. Okay, let's do get axis raw debug. And I'm gonna put this, okay. I'm gonna put this on my plane. Then I'm gonna open it up. I'm gonna do this. I'm gonna do print input dot get axis raw. I'm gonna do that twice. Then this one is gonna be horizontal. This one is gonna be vertical. Great. Please work. Huh. I'm so confused. And I don't know why this isn't going down. Wow. Why is this not working? What? Yeah, I mean, like, yeah, it's not actually working. What? Virtual joystick. I don't have. Okay. Okay. You gotta be kidding me. Huh. Huh. Alright, yeah, okay, never mind. I'll figure it out off stream. Great, that's it for this stream. Thanks so much for joining me. Thank you for spending your most valuable resource of time in your life on watching my stream. And have a good one.